Okay, so we're now completing the square for this. Okay, so we get a new page. Should have got that first. Okay, we try to factorize, always try to factorize. Usually they give you a clue, like solve to 3 significant figures, in which case they're telling you it's difficult. Okay, so in this case it's an equation, so we can divide by 3. So it'll be x squared minus 10x over 3 plus 8 is equal to 0. So it's going to be bracket x minus, now then what would it be? Quick?
5x.
Sorry?
5x over...
I didn't hear that right, I don't think.
10x over 6.
Well, best answer is 5 over 3, surely. No x. So it's, you halve the coefficient of x. Now we minus that squared, which is 25 over 9 plus 8 is equal to 0. So x minus 5 over 3 squared. What do I do next? Well, I cross those over, so it's going to be minus 8, add 25 over 9. Now I can see something there. What do you notice there?
That you can cancel.
Well, this is no. This is going to be a minus answer. So in fact, I invented this sum, and there's no solution to it, because x squared here is less than 0, because this is going to minus answer. This is minus 8 plus 3, if you like. So it's minus 5. So there's no solution to this. So no solution to that particular sum. Okay. Next, we're going to have a look at inequalities. Well, look at examples they're asked us to solve. Anything?
No.
It says here, numerical methods use systematic trial and improvement methods. So you have to solve this, for example. X cubed is equal to x minus 900. Right, now you might think that x would say, I don't know, maybe 5. So we say, look, x equals 5. Now I think first of all I'd rearrange that. So I would get x cubed minus x plus 900 has got to equal 0. That's the object of the exercise. When x is 5, we'll have 125 minus 5 plus 900, which is clearly nowhere near 0. Does not equal 0, nowhere near. So what would we try?
9.
Okay, we could try 9. So x is equal to 9. So that would be 9 cubed minus 9 plus 900. If that doesn't work, we might try 8 or 8.5. But it says systematic. It doesn't mean have a wild guess. Don't say 9 didn't work, so I'll try 1. And 1 didn't work, so I'll try 12. That's just having a wild guess. Yeah. Okay. Next thing we're going to look at graphs of functions. Okay, forget that. Y-intercept. I mean, obviously everybody knows y equals mx plus c is a straight line going uphill. Okay. A perpendicular. Know that the lines represented by the equations y equals. Okay. What it says here is know that y is equal to minus 5x, and y equals 3 minus 5x are parallel. Why are they parallel? Well, exactly. So the gradient in this case is minus 5, and the gradient in this case is minus 5 if the gradients they're parallel. And then we want perpendicular lines. Okay, so this line here, suppose that has the equation y is equal to, say, 3x plus 7. What would be the gradient? No, that's not very good. What would be the gradient of the perpendicular here? So what would y equal here to start off with?
Minus 3x.
No, it isn't minus 3x.
1 over.
It's minus 1 over 3x. And this could be anything here, because all these lines here would all be the same as that, and the c would be different. So in fact, if the gradient of one line is, say, 2 over 3, the gradient of the perpendicular is upside down, so it's 3 over 2 with a minus. If the gradient of one line is equal to 7 over minus 2, the gradient of the perpendicular will be 2 over 7, change the sign so it disappears. Okay. Construct linear functions, plotting corresponding graphs with real life problems, forget all that. Quadratic, well, the thing to here, y is equal to x squared plus 3x plus 4 is a valley shape. That's a valley shape. If it had been y is equal to 3x plus 4 minus x squared, that will be a mountain kind of shape. Okay, this graph here, y is equal to 1 over x. When x is naught, you get it. Well, when x, let's suppose x is equal to 0.00001. 1 divided by that will be slightly off the graph, I think you'd find. It'll be way up here off the graph. So in fact the curve comes down like this and along like that, as it were, and then it will come along here like that and down. No, it won't. It doesn't cross over there, that's wrong. Okay, but I hope you get the idea. Okay. Now what about y equals it? They also want you to plot y is equal to x cubed. Y is equal to x cubed. Well, do we know the answer? Do we know what that looks like? Well, when x is naught, it's going to be naught. When x is 1, it's 1. When x is 2, it's going to be 8. When x is 3, it's 27. So the curve comes down like this, and then it goes down like that. Very poor sketch. Oh, then you also want this one here. Y is equal to 2 to the power x. I mean, that's more interesting. Now, what's 2 to the power naught?
No.
What is 2 to the power naught? I had one answer. Is 1, okay. So that will be 1. And when x is 2, what would y be? This is 1, remember, this is 1. If x is 2, what would y be? Quick, quick. The people are waiting for your answer.
4.
4, thank you. Right. And when x is a half, in fact, the curve comes down like this. Like that, okay? And it won't actually get, but it won't get negative. Okay? And if what would y equal 3 to the power x, what would that look like? Well, when x is 0, what would y be? So it goes through here. So they all go through here. That's the Piccadilly Circus or Trafalgar Square. When x is, so it'll be steeper, but it will still go through Piccadilly Circus or whatever. Transformation, this is a bit complicated as well. If they give you a graph, we're on 500 seconds, I haven't got many seconds left. If y is equal to fx, and we're asked to draw y is equal to, say, 2fx, what happens to the graph? So the first graph, I'm going to do that. What would this graph look like?
It would be 2 up.
Say again?
2 upwards.
Say again?
2.
2 to the right, wouldn't it?
No, it would be twice as tall. So it would be twice as tall, twice as tall. If this point here was, say, 7, if, then this point would be 14. It's twice as tall. Right, what would happen to fx plus 2?
Move up to.
Yes, it would move up to. So it would go up to 9 in this particular case. So it goes up to like that. Okay, it just goes up to... No, it doesn't. Yes, it does. That's correct. That's correct. What happened if it being this? Y equals fx... minus 2 here. What would that do to it?
Move it to the right.
To the left.
To the left, sorry.
Which is right, which is left. So I'll draw the graph. I'll say it's there, like that, and I'll say this is 2, and I'll say this is 4. So what happens to it?
Moves to the left.
No, it moves to the right. It moves the opposite of what you think. It says minus 2, so the curve will move to that way, right?
Okay.
You ought to, this is an interesting question, you need to know the equation of a circle is x squared plus y squared equals r squared. They have had a question on that in the exam where you've asked to plot it. It gives you a circle. Okay, that's the end of that for the minute, I'm afraid.